So hello students, Namaskar, Adab, Sat Sri Akal. How are you? I hope that you are doing good. So in yesterday's last lecture that we have studied, we have completed part 1 of capacitor. We have seen about the formulas, basic formulas of capacitor, what was the energy stored in a capacitor. If I will quickly take a recap about some of the important formulas, what we have written, that first formula that we have studied is Q is directly proportional to V, from where we have written that Q is equal to C into V, and C was what? Capacitance. We have discussed in depth about capacitance, and then we have written capacitance is equal to Q divided by V. Okay, that was the basic formula. It was calculated. What was the units for calculating capacitance? It was farad, and I told you mostly it is calculated in microfarads. Okay. Now if you ask you about energy, how much energy was there? If you calculate energy by the integration work done, you have calculated work done, from there you got energy that was equal to half CV square. Or also you can write the same formula as Q square by 2C. Both were the ways to remember this formula. Then we have written, if there is someone is asking you what is the energy loss when work is done, when you are charging any capacitor, there is always some heat loss, or you can say some energy loss. How you will write that? You will write initial energy minus final energy. Now I told you how to write initial energy also. How you have written initial energy? Initial energy was written as half C1 V1 square plus half C2 V2 square. This was the initial energy. And then you have written the final energy. How you have written the final energy? I told you till what time charge will be getting transferred, until and unless both the capacitors are at the common potential. At the common potential, that means final potential will be same. That is what you write, half C1 plus C2 into V square. That was the common potential. This was U initial, this was U final, and the last question that we have solved was also on the same concept. So now we are going to start further from here. The topic will be combination of capacitors. Now of course there are two basic combinations. One is series combination, one is parallel combination. In resistance also you have studied about this. In series combination resistor, what is the formula for resistor? R1 plus R2. If I am talking about two different resistors, R1 and R2 connected in series, what is the formula? R1 plus R2, and in parallel what it will become? 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Now see, here are also two kind of combinations. One is series combination and second one is parallel combination. It will have a common node and it is having a common junction. Okay. So what do you know about here? That the potential difference across a parallel capacitor will always be same. What about the potential difference across this one will be the same potential difference across this one. How we write this? Let's suppose at this point some potential is VA. If this point is A, I am assuming that some potential is VA. And at this point I will say that some potential is VB. So when I have to write a potential difference across this capacitor, one what I will write? VA minus VB. And if I have to write the potential difference across the second capacitor, what I will write? Again I will write VA minus VB. What I will write? VA minus VB. So can I say across both of the capacitors parallel potential difference is same? This kind of combinations, when potential difference is same, this kind of combinations are called as what? Parallel combination. Series combination, potential difference will be different. Here you can assume this as some point x, this will be at some point x potential. If I will ask you, tell me the potential difference across this capacitor one, how you will write? You will write VA minus x, and across this what you will write? VB minus x. That means I can say potential difference is different. But what is common in series combination? Common will be in resistor. If you remember the basic thing, anyway the next chapter is current resistance that we are going to discuss. But here we talk about not the current, we talk about charges. So whatever the charge will be present on this C1 capacitor, same charge will be present on the C2 capacitor also. And this will be the basic to derive the formula as well. So let's see firstly series combination. For series combination, what I have already told you, that charges will be same and it is connected by some battery V. Let's write how I am going to write. Let's suppose across this potential difference is V1, across this potential difference is V2, and across this potential difference is V3. Different potentials, and a battery is connected. Let's suppose there is a higher polarity, this is the lower polarity, this potential is V, this potential will be 0. And I can say one more thing, that all of these are charge Q, carrying charge Q, carrying charge Q, because charge will be same. So according to that, what I can say, now the theoretical terms are given here. You have to write in the final exam, you will write this much of things, then you will get good marks in board exam. But conceptually how you will derive? You can say that final potential that is given, V, that is the battery, it will be equal to the sum of potential difference across capacitor 1 plus potential difference across capacitor 2 plus potential difference across capacitor 3, V1 plus V2 plus V3. Now tell me how you write potential. What is the basic formula? Q is equal to C into V. That means V can be written as Q divided by C. Correct? Q divided by C. Here what we write? Net potential is equal to net charge, that is Q divided by C equivalent. The final equivalent capacitance that will become. V1 how you write? You will write again the charge is same, Q divided by C1. V2 how you write? Q divided by C2 plus V3 how you write? Q divided by C3. Now Q will simply get cancelled out, and what is the final result that will become? For series combination, C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This will be the result. And you can notice that this kind of same result was coming in parallel combination of resistance. Resistance parallel combination is the series combination for capacitors. Always remember this. There is if I am talking about resistance in series, that is R1. If three resistors are connected, that will be R1 plus R2 plus R3. But if I am talking about capacitance series combination, it will be 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So there is a difference between them. Don't get confused ever between. So this was the part, and now you will write that much of that much of diagram to have good marks in board exam. Here is a complete derivation given also. For two capacitors, if I will ask you, you need to remember the direct results, because for solving purpose in cooperative exams it is very much important that for two or three capacitors you are directly remembering the results. For two capacitors connected C1 and C2, what is the C equivalent? Directly you will write. Actually, the formula, if you want to derive, you can write 1 by C1 plus 1 by C2. How you solve it? Multiply here, take the LCM. It will be what? C1 C2 divided by plus C1 plus C2. That is equal to 1 by C equivalent. That means finally C equivalent can be directly written as C1 C2 divided by C1 plus C2. Product divided by the summation. That is the direct result you can say. And if the magnitudes are same, simply it will become C by 2. Just make it half. How? C1 C2 eventually it will become, if C1 and C2 are equal, it will become C square, and C1 plus C2 it will become 2C. C cancel, it will be eventually become C by 2. So these two basic and direct results that I will say that you should remember always. Now let's have a basic question. Try to solve it. Three capacitors. What is the question? Three capacitors, each of capacitance C. Three capacitors are there, and breakdown voltage is V, are joined in series. This kind of three capacitor combination is given to you, connected in series combination. The capacitance and breakdown voltage of the combination will be. The capacitance and the breakdown voltage of the combination, the question is asking you. Three capacitors in series combination of equal magnitude, what you will say about C equivalent? Firstly calculate C equivalent. What will be C equivalent? 1 by C1 plus 1 by C2 plus of 1 by C3. That is what you will say, it will become 3 by C, 1 by C equivalent. That is finally what you can say C equivalent. C equivalent will be equal to C by 3. C equivalent is equal to C by 3. That means what are the two options? Either option A, either option C. Now we have to check what will be the net breakdown voltage of the combination. Across C, first one it is given as V. Across this one it is again given as V. Across this one again it is given as V. That is what you will say, the net breakdown voltage of this complete circuit. It will be V1 plus V2 plus V3. That is V plus V plus V. That means finally how much voltage you will be getting? 3. So which option is coming correct? Here you can say C by 3 into 3. Option C will be correct. Is it clear? So this way easily different kind of questions are there for combination questions. Here you can see the complete solution is also given. C by 3 and 3B. Now come to parallel combination. Parallel combination. Now if you are having the formula of series in series combination, it was a formula for parallel. That means in parallel the formula will be coming for series of resistance. Okay? And let's see how it will be coming. Now this is a parallel combination. What I told you about the property of parallel combination, that is important. From there everything will be derived. You will say that whatever the potential difference across this capacitor 1, let's suppose potential difference is V, that will be same across here also, that will be same across here also. But this time charges will not be same. Let's suppose some net charge Q is coming. Here it will be going Q1 charge, here it will be going Q2 charge, and here it will be going some Q3 charge in the third circuit. Okay. That is what I can say from here. Whatever the net, if I am applying KCL, basic KCL, I can say right Q is equal to Q1 plus Q2 plus of Q3. Now write what you can write for Q. Q is equal to C equivalent into V. But whatever the battery is connected, potential difference. Here potential difference that you have generated is this point is at potential V, this point is at potential 0. That means the net potential difference across this complete system is V. Now what you write across Q1? What is Q1 charge? You will write always C into V. That means what you will write C1 into what is the potential difference V plus what is the charge flowing to the second circuit? You will write C2 into V. What is the charge flowing to the third circuit? That is equal to C3 into V. This V simply get cancelled out, and what will be left? You will write C equivalent is equal to C1 plus C2 plus C3. And can you say this is the same formula, same kind of formula for series combination of resistance, but here parallel combination have this kind of formula. So don't get confused in series combination and parallel combination. This is what we can. Now if someone asks you to apply KVL, how you will apply KVL, that's also understand a little bit. So in good kind of questions where you will have to apply KVL in a loop, how you will write. If you remember, anyone, I will revise a little bit of current electricity from your basic classes that you have written. If this is a battery, let's suppose potential given for the battery is E, and this is second case. This is point A, this is point B, this is again point A, this is again point B, and these things. Now in KVL, when you are crossing this battery from lower potential to higher potential, this represents what? Lower potential, and this represents what? Higher potential. When you are going from lower to higher potential, you write the potential difference across the battery as plus C. And when you are going from higher potential to lower potential, you write the potential difference across the battery as minus of E. So this is the one thing that you will be used here also. If you are crossing a capacitor, how you write the potential difference across the capacitor? Now let's see here. Let's suppose you are going from here to here. From the this is plus Q and this is minus Q. Already I told you one plate will be at positive charge and one plate will be at negative charge. Magnitude will be same. Now here what you are doing? You are going from higher potential to lower potential. Going from higher to lower, what you will get? Plus or minus? You will get minus. Going from higher potential to lower potential, potential difference will be minus of Q by C. And in the second case, if you are moving from lower to higher, you are going from lower to higher, you will get plus of Q by C. This is the basic difference. Now apply KVL in this complete circuit. There is a circuit given to you and you have to apply KVL in this complete circuit. Start from point B. How you write KVL? Anyways, you study a lot in depth in current electricity topic also. Start from point A. Let's suppose the potential at point A is VA. Okay. Now what is the next thing coming in between? Now you will be reaching to point B. But how you write the potential difference across this capacitor? One is Q1 charge and one is minus Q1 charge. How you write potential difference? Potential difference is what? First you remember the formula. Potential difference you can write Q by C. Now what is the charge? Charge you will get Q1 divided by what is the capacitor? C1. But the question will be coming plus or minus. Now see here. You are going from positive charge to negative charge. That means from higher potential to lower potential. Going from higher to lower, you will use minus sign. Correct? Now you have reached till B. Now make a jump and reach to point C. This time again how you write the potential difference across this Q by C. What is the charge present on this capacitor? You will write Q2 divided by what is the capacitor? C2. Again the question will be coming plus or minus. How you write? You are again going from positive charge to higher potential to lower potential. Higher potential to lower potential always it is a negative. That is again you will write a negative. Then after that what you will do? You are coming here. Now you are going from lower potential to higher potential to cross this V2. Lower potential to higher potential, what you will do? You will write plus of V2. Then you will be coming here plus of V1 again, because here it is showing you lower potential. Here it is showing higher potential. Going from lower to higher, it will always be positive. And I can say now again you reach to same point A. This VA cancel out, and what is the net equation you can write for this KVL when you are writing this to V1 plus V2 minus Q1 by C1 minus of Q2 by C2 is equal to 0. This is the way you will apply KVL in any kind of loop. This will be the final equation. It have a wide spread of applications. When you will be in the question series, we will see a lot of applications, not only for capacitance topic, it is also valid for current electricity. The same way we apply there also KVL in any kind of loop. The important thing is what, if I will tell you the summary of this thing. Always remember, when you are going from higher to lower, it is negative, and you are going from lower to higher, it is always positive. This is the one thing that you have to always remember from here. Same way it is applied KVL into the system. Now I have a question, basic question, how to solve it. A capacitor of take the a capacitor of capacity C1 is charged up to voltage V and then connected to uncharged capacitor. Firstly, there is a capacitor C1 that was uncharged and now it is charged to potential V using a battery. And then this charged capacitor is connected to an uncharged capacitor C2. The diagram is reflecting completely. Uncharged capacitor C2. Final potential difference across each will be. You have to tell me finally what will happen. Actually, what will be happening in the phenomenon? Last class I have told you about redistribution of charges. It got completely charged till charge Q. Okay. Now what will happen when you have connected an uncharged capacitor? Now what will happen? Charge will start traveling from this charged capacitor to this uncharged capacitor. That means it will also try to charge this second capacitor also. But until what time? There is some limits and restrictions also. So it will charge the second capacitor until and unless the potential difference across both these charge capacitors is V, common potential, that I told you. Even a direct formula I told you how to remember this common potential. But still, let's again write it. So what you will do? I will apply the concept of conservation of charges. What conservation of charges say? It says that initial charge is equals to final charge. What it says? It is equal to initial charge is equal to final charge. What is the net initial charge you can write? It is charged to capital Q. That means in terms of Q is equal to C into V. I can write it as C1 into some potential V. It is have been charged. Now what is the final charge? You can say final charge is present, that is equal to Q1 and Q2. Final charge, or one more way you can write this as Q is equal to Q1 plus Q2. And how you write Q1? Q1 can be written as C1 into some V common plus C2 into some V common, because finally the potential that is present here is some common potential that you are going to write. Now the question is solved. Here what you will do, you will take common V common that you have to find in the question. It will be C1 plus C2, and here it is what C1 into V. That means common potential that you are going to write, it is equal to C1 V divided by C1 plus C2. V common is equal to C1 V divided by C1 plus C2. That is the final answer. Which option is coming correct? Second option. Just what was the concept that we have applied? Charge, conservation of charge. That is very important. I am telling you from the first lecture of electrostatics that conservation of charge is always valid. That is applicable. There are some properties of charges in the topic I have discussed this thing. Next question. 3 capacitors, each of capacitance 4 microfarad, are to be connected in such a way that the effective capacitance is 6 microfarad. This can be done by 4 options are given. What is the combination that it is a very good application question of combination of capacitance. 4 possibilities are given. Either you are connecting all of them in series, either you are connecting all of them in parallel, either you are connecting 2 in series, 1 in parallel, either you are connecting 2 in parallel and 1 in series. What kind of combination you will be making for 3 identical capacitors to make the final net equivalent capacitance is equal to 6 microfarad? Let's try one by one. Coming to the first step, A option. You are connecting all of them in series. All of them in series. That is this kind of combination you are getting. You know that for series combination you will write 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. That means can I say C equivalent is equal to net C by 3 and what is that means come to option B. What option B say? All of them are connected in parallel. Connected in parallel, what is the formula of C equivalent? C equivalent can be written as C1 plus C2 plus of C3. That means can I say C equivalent is going to come in as 12 farad. Farad is equal to microfarad. more usually coming in current velocity. Current velocity is filled with this kind of things. Simply to understand one thing, that across parallel combination, what I have told you, that potential difference will always be same, and across series combination potential difference is different. That's it. That is more sufficient. Here this point is what? A. Then let us assume that this potential will have some VA potential. I don't know, but I will write this point as some VA potential. Now state wire is connected. State wire means what? Potential will always be same. That means this is connected with this point. That means this point is also at potential VA. That. Now anything that you can say about this potential? No. Here this point is B. What you can say about this potential? This potential is VB. Again it is connected with a straight wire. That means this is also a point that is connected at potential B. That means it is also VB. Now check what is the potential difference across all these three capacitors. What is the potential difference across this capacitor? What? VA minus VB. If I will ask you to write the potential difference across each capacitor, what you will do? You will write potential difference here is VA minus VB. If I ask you to tell me what is the potential difference across the capacitor 2, again you will say V1 minus V2. And now if I ask you to tell me what is the potential difference across the third resistor, again you will say VA minus VB. Now if I ask you, can I say that potential difference across C1, potential difference across C2 and potential difference across C3, all these three are nothing but same. If potential difference is same, that means what I can say, I can redraw this diagram as what? See here. I will say this point is A, and I will connect all these three capacitors in a parallel combination. Reason, potential difference across all of these is VA minus VB. That is across same potential. That is C equivalent. I can write that will be equal to C1 plus C2 plus C3. So we have manipulated this complete circuit that was given as a simple circuit of parallel combination, and this is what the concept of this wire connection problems. Now again there will be a lot of varieties. It depends on the practice, how much practice you are doing. Finally C equivalent will be coming equals to C1 plus C2 plus C3. Now the next one is Wheatstone bridge. Wheatstone bridge have two kind of Wheatstone. One is balanced Wheatstone, second one is unbalanced Wheatstone. Now see, what is Wheatstone bridge combination? It is a combination of five kind of. Now it is valid in current electricity as well, and it is valid here also. There is not any separate concept of in current electricity. If you know the Wheatstone bridge of current electricity, that is the same thing here also, but it is more often used in current electricity. It is a combination of five resistors or capacitance. I will say C1, C2, C3, C4 and C5. Now there are two kind of Wheatstone bridge. Now complete theoretical part is given here. You can read it out. I am telling you the things that that is important to understand from here conceptually. Now there are two kind of Wheatstone bridge. One is called as balanced Wheatstone bridge and another one is unbalanced Wheatstone bridge. What is the meaning? Let's suppose some potential X is present here. Okay. And if at this point also the potential is same, that means potential difference across C5. If I will say that potential difference across C5 is equal to 0, then it is called as what kind of Wheatstone bridge? Balanced Wheatstone bridge. And we generate some condition for balanced Wheatstone bridge. That means automatically what will be unbalanced Wheatstone bridge? If the potential difference across the capacitor 5 that is connected in between in this kind of combination, if it is not 0, then it is a kind of second case, that is unbalanced Wheatstone bridge. Anyways, the majority of the questions that will be coming in our exam is from Wheatstone bridge. This is the same thing that is explained here in theoretical term for board exam, if you can refer it. So here it is also represented. If this potential is X, this potential also have to be X. That means if can I say if potential difference is 0, that means this complete circuit you can remove from here. It is of no use, because what you write the equation V is equal to Q divided by C. If this is 0, what I can say it is net charge that is present. Net charge present is also equal to 0. That means this is of no use. You can remove this simply from the circuit. And once you remove it, what you can write as the equation? Let's understand it next one. Now see how you create the condition for it. This is a direction that may be coming in your board exam. Tell me one thing. If I ask you, tell me potential difference across C1, how you write? Potential difference across C1. I will again tell you what is the formula of writing potential difference. Potential difference can be written as simply Q divided by C. Whatever the charge present, whatever the capacitor present. Now if I ask you potential difference across C1, what you will do? This point, this is battery is connected. This point is 0. This point is I have taken as V. I know I have the liberty to take any point as V potential, any point is 0 potential. So I will say this point is V. If this point is V, what I can say about this? This will become 0. Connected by a straight wire, then this point is also 0. This point is also 0 potential. This one connected by a straight wire, that means this point is also V potential. This point is also V potential. Now simply tell me what is the potential difference across capacitor 1. How you write? You will write V minus X is equal to, what is the charge present on capacitor 1? Q1 divided by C1. This is the first equation. Now I will ask you, tell me what is the potential difference across this C3 resistor. Again you will say same thing, V minus X, but the charge that is present on this C3 capacitor is Q2 divided by C3. Correct? Let's suppose this is equation 1, this is equation 2. Now take the ratio of both equation 1 and equation 2. When you are taking this ratio, this will be simply cancel out, that will be equals to 1, and what you will do here, you will write Q1 by Q2, it will be equal to C3 by C1, and here it will be coming, that means it will become C1 by C3. Correct? I can say Q1 by Q2 is equal to C1 by C3. This is what I will write as equation 3. Now again come to the other capacitors also. Write the capacitor, a potential difference across this capacitor 2. How you write a potential difference across this capacitor 2? You will write X minus 0 is equal to, what is the net charge present on this capacitor? It is Q1 divided by capacitance is what? C2. Again write the potential difference across this capacitor 4. How you write? This potential is X, this potential is 0, that means X minus 0 is equal to, what is the charge present? Q2, what is the capacitance there? C4. This is, let's suppose, equation 4, this is, let's suppose, equation 5. Now take the ratio again. Take the ratio for both of these. Again what I will say, Q1 by Q2 is equals to, here what we will say, this is going to be C2 by C4, and now you are changing the direction, and it will be equal to C2 by C4. This is what, let's suppose, equation 6. Equation 6. Now check equation 3 and equation 6. What you will be getting? What will be getting? Q1 by Q2 is equal to C1 by C3, and again here Q1 by Q2 is equal to C2 by C4. Combining equation, where should I write? Just here understand. Combining equation from equation 3 and equation 6, what I am getting, I can write C1 by C3 is equals to nothing but C2 by C4. That is what I will say, where from the condition of balanced Wheatstone bridge, I can say the ratio of C1 by C3 should be equal to the ratio of C2 by C4. This is what this important condition is, and the questions are solved based on this condition that we have generated here. So let's see kind of question, what kind of question can be coming from here. This is the net capacitance is also written here. What you can say about the net capacitance? Let's calculate that also. Now I can say here it was originally connected C5, but since I know that it is a balanced Wheatstone bridge, that means simply I can remove this capacitance. This is of no use, so I will simply remove it. Once I remove it, that means what kind of combination I am getting here? This is a series combination. This is a series combination. For series combination, what is the formula? C equivalent 1 by C1 plus 1 by C2. That means what I will write? For the first combination, I will write C1 C2 divided by C1 plus C2. For this combination, I will write C1 C2 divided by C1 plus C2. For this combination, what I will write? C3 C4 divided by C3 plus C4. Correct? Both are in series combination. Now the net equivalent relations on the net diagram that we will do, this will be one C equivalent, this is the second one. Now can you say both of them are parallel, and if both of them are parallel, simply add up both of them, it will become C3 C4 divided by C3 plus C4. That's it. कोई लागे? नहीं, बस आवाज होनी चाहिए. It will be C3 C4 divided by C3 plus C4. Correct? So this is up to you if you want to remember. Otherwise, it is a very simple thing. I don't think so that you need to remember this also. Now here a kind of balanced Wheatstone bridge is given. How I judge that it is a balanced Wheatstone bridge? I can say take the ratio. How I judge that it is a balanced Wheatstone? If the question is actually asking you what is the net effective resistance between point X and point Y, this is what you have to solve. So let's see how I can judge. See, this is a kind of combination given here: C1, C2, C5, C3, C4. What I have told you, always take the ratio. This that is present here: C1, C2. Take the ratio. What is going to become C1 by C2? Can you say this ratio is going to become as 1? Now take the ratio C3 by C4. That is the ratio again C3 by C4. Can you say this ratio is also coming to 1? And if they are equals to each other, that can you say it is nothing but balanced Wheatstone bridge. And if it is a balanced Wheatstone bridge, I can simply remove this one from this diagram. Correct? Now what is the new diagram that I can draw? I can write this as C1. This is a C2, and eventually all the things are given as same. So simply write 6. This one is also 6. C5 is removed. This is also 6. This is also 6. This point is X. This point is Y. Now tell me, what is the net equivalent resistance? Capacitance. Sorry, capacitance. You will say simply these two are in series. These two are in series. Series. That means eventually it will net will become 3, and here 6 will become 3. Now this complete combination are in parallel. Parallel means which kind of formula? C1 plus C2. That means 3 here, 3 here. Both are in parallel. That means finally answer will become 3 plus 3. Answer will be 6 microfarad. Which option is coming correct? B option. Final answer will be coming equals to 6 microfarad. Series parallel, just you have to understand. And one more thing you have to understand, that when this condition is generated for balanced Wheatstone, that is the most important. But because the questions will not give you directly that it is reflecting that it is balanced Wheatstone bridge, you have to generate the condition for this balanced Wheatstone bridge. Finally, answer is 6 microfarad. Same way. Now it is about parallel plate problem. Anyways, we will discuss more about this kind of problems in dielectrics also. That is the next portion of this chapter. But still here also, how we will resolve these questions. Let's suppose 3 capacitors are introduced here. Some different diagrams is mentioned, but the concept will be still same. What is the concept that you remember? For parallel combination, potential difference is same. For series combination, potential difference is different. Now here, what is the concept? That 3 capacitors are connected. I guess the values are given same: D width, D width, D width. What is the capacitance for parallel plate capacitor? It is nothing but equal to A epsilon naught by D. That means I can simply say C1 is equal to C2 is equal to C3, and all of them are nothing but equals to C. Now the question is how they are arranged. Which one of them are in series combination? Which one of them are in parallel combination? That is the actual thing that the question is trying to ask you. Now see the connections properly. Here is a battery connected from this plate V, and this is at 0 potential. This point is at X potential, this point is at X potential. Just write the potential difference. Always this method is going to work for you. Just tell me what is the potential difference across this C1 capacitor. If I ask you, one plate is at X potential, one plate is at V potential. That means what is the potential difference? You will say it is nothing but X minus V. Potential difference across the capacitor 1. If I ask you the potential difference across these two plates, what you will say about the potential difference? This point is at V potential, this point is again at X potential. That means I can say this one is also at X minus V potential. If I ask you the potential difference across the capacitor 3, this point is at X potential, this point is at 0 potential. That means I will write X minus 0. That means what I understood from here, that first two capacitors are potential difference same. That means they are connected in what kind of combination? Parallel combination. And the third capacitor is connected in series combination with it. That means what kind of diagram I can make? I will write these first two capacitors. If I am naming that, this is C1, this is C2. These two are connected in parallel combination, and this parallel combination is connected in series combination with the C3 resistance. Now tell me, if the magnitudes are same, what will be the net equivalent capacitance? You can write C equivalent can be written. Parallel combination, same magnitude, C. Parallel combination, same magnitude, that C equivalent will be for this portion as C by 2. And now it is it will not be C by 2. It is a formula of series combination. If it is connected in parallel, formula will be for series. That is here what you can say C equivalent. It will be 2C, and this C and this 2 C equivalent is equal to C3. That means what you get. These two are in series. Finally, the next diagram that we will be drawing. This will be the final equivalent diagram. 2C and C are in series. That means finally C equivalent what you get. C equivalent is 2C into C divided by 3C. C equivalent will be 2C by 3. Finally, simply your answer will be like this. So it doesn't matter what kind of combination is given, wire problem, direct problem, or this kind of 3 plates are directly connected and some weird diagram is there. Concept is always same. Parallel combination, potential difference will be same. Series combination, potential difference will be different. Now you just have to write the potentials. Just start writing the potential at every point. Ask yourself a question that what is the potential difference across this capacitor. Write that potential difference. Everything will be simply clear to you. The more questions you will practice, the more easier it will be feeling. Same thing. Finally, answer will be 2 by 3. Here 2 and C will be becoming series. Formula will be applied for parallel and C value already we have calculated. This is nothing but A epsilon naught by D. Now here the question is what? Read the question. 2 condenser I have already told you condenser is also used as capacitor, the term used for capacitor. One of the capacity at C, there is a diagram also made, and the other is capacity C by 2 are connected to B by a battery V. They are connected by a battery V. As shown in the figure, the work done in charging fully both the condensers. What you have to do, work done to charge both the condensers. What is the formula of work done? If I will tell you, half C equivalent and the battery is connected as V, that means half C equivalent V square. Eventually the question is very easy. The question is asking you only what will be your C equivalent. Tell me what will be the C equivalent. 2 combinations connected in parallel combination, that means formula will be applied for series operations, that means C equivalent will be C plus C by 2, that means net capacitance will be 3C by 2. 3C by 2, that means just put in the formula, work done is equal to half into C equivalent, that is 3C by 2 into V square. Final answer will be coming 3C by 4 into V square. 3C by 4 or 3 by 4 into C V square. That means which option is coming correct? Option 3 will be simply correct. Nothing, the question was not asking me any specific thing. The formula that I told you is the formula that we have derived in the last lecture. Work done is equal to half CV square, and then I have just calculated the C equivalent of the circuit, and that's it. This was the answer. Okay. This is also a question that is important question. A very weird looking kind of circuit is there. A cubical circuit. It is also given in NCERT. How you will calculate the net capacitance between 2 points are there. 2 points that you have to understand. This is point A. The question is find the equivalent capacitance between point A and point B. This is what how you will calculate. So solving this question, there is a fixed method that you should follow, and you will be getting the answers. Please listen carefully. Assume some charges flowing through it and draw the charge distribution. Because all these are equivalent and symmetric diagram, I will say that let's suppose, and this is at let's suppose higher potential plus, and this is at some lower potential, and you are going from higher to lower potential, that way you will be taking negative sign and it will be. Let's assume some 6 coulomb charges flowing through point A. Now it is distributed into how many circuits? This is one circuit, second circuit, third circuit. Imagine it is in 3D. There is a cubical block and all of them are completely symmetric. There is no problem of symmetry. That means can I say it will be divided equally? How much it will be divided in all those 3 circuits? Here it will be going 2 coulomb of charge. Here it will be going again 2 coulomb of charge, and in this circuit also it will be going 2 coulomb of charge. Clear? Now come to this junction. Till here how much coulomb charge is coming? 2 coulomb. Now from here how much charge is distributed? Again it is distributed into 2 combinations. Here it will be going 1 coulomb charge, here it will be going 1 coulomb charge. This circuit is also done. Now come to this junction. Till here it is 2 coulomb charge. Now again it is distributed into 2 circuits. That means here it is again going 1 coulomb charge, again here also it is going 1 coulomb charge. Come to here, till here it was coming 2 coulombs of charge. Finally it will be going here 1 coulomb, because again it is distributed into 2 sections. Here also it is going 1 coulomb of charge. Correct? Now finally at B also, can I say net charge that will be coming will be equal to 6 coulomb, because whatever the net charge that is coming in entering into this section, it will be exiting out also, that will be equal to 6 coulomb. You can cross check also. From here it is coming 1 coulomb, this is again 1 coulomb, that means net here it will be coming 2 coulomb of charge. See in this section, here it is coming 1 coulomb, here it is coming 1 coulomb, that means in this section also finally it will become 2 coulomb, from here also it is coming 2 coulomb. Check for this section. Here it is coming 1 coulomb, here it is 1 coulomb. That means in this section also finally it will be coming 2 coulomb of charge. That means 2 plus 2 plus 2. Finally at 6 it is exerting how much charge? Obviously, whatever the charge that is inserted, that is the net charge that is coming out of this circuit also. So what we got from this doing this charge distribution? I will tell you what. If I ask you, tell me what is the net potential difference across VL, A and B? What will it say? What is the formula in terms of capacitor? It is net charge divided by C equivalent. Correct? What is the net charge that you have flown into this circuit? You will write 6Q is the net charge that you have flown divided by equivalent capacitance. It is equal to equivalent capacitance. Now apply KVL. I have told you how to write KVL from point A to B. Take any one section of your potential difference, you will write across this one. Again you will write minus. What is the net charge flowing through this? Okay. There right 6 coulomb charge. There you will write 2 coulomb charge. Now tell me in this section of this how much charge is coming? It is again 1 coulomb divided by capacitance, that is C. And in the final section of this section, now where you are reaching at point B, I will write how much charge is coming. Again 2 coulomb charge divided by C. 2 coulomb charge. Now don't cancel the C and C. So eventually what I can say, on this side how much capacitance is there? 6C divided by C equivalent. And here it will be how much? Minus of 5 divided by C. Coulomb is just the unit. Then if I ask you, tell me, and there is a negative sign also, this negative will get cancelled. If I have to write the C equivalent, how you write? This 6C will be going here divided by 5. 6C divided by 5, what is the answer? Which option? 6C divided by 5, that is which option is coming correct? D option I can simply correct. So what I have concluded, I have write KVL. Basically KVL, and about KVL I have told you, whenever you are going from higher potential to lower potential, you write it as minus, and when you are going from lower to higher, you will write it as plus. And I have told you how to write potential difference across all the resistors. It is equal to Q divided by C. Firstly, I have drawn the charge distribution. It is valid for any kind of circuit. Now it is same kind of thing we are going to do in the current electricity also. There only change will be coming, that there will not be charges flowing, there will be current flowing into the circuit. And same way we will do the current distribution. Then again I will apply KVL into that section also. And then finally I will write what will be the R equivalent into those kind of. So this is it for today's this lecture. Next lecture we are going to see for dielectrics. So until next time, keep learning, keep going. Tapasya, and they go, Nama Tapasya.